All right, so in number 1, the first thing I would suggest that you do is sketch a picture of this if you can. You've got the graph of 1 over x. So I'm going to go ahead and just put this part because we just need what's going on in that first quadrant. Now 1 over x certainly has back here, but we're not going to be using that. And so we have y equals 1 over x. What else do we have? X equals m and x equals 2m.
Can you give me another one? This one's wet now.
Okay, now we're going to do x equals m. So that's going to be your vertical. It's going to be somewhere here.
How do you know that?
Because m is positive and it's x equals. So it has to be somewhere over there. And then x equals 2m, well that's bigger than m, so x equals 2m is going to be somewhere over here. And again, that's just in general. I don't actually know what m is, and I really don't have to know what m is to solve this. So you're looking at the bounded region here. That's what you're looking for. So to set this up, now you do have to know your endpoints, but I know I'm going to be integrating from m to 2m, because there's your x values, isn't it? That's really what they're giving you there. They're telling you the order when they tell you m's greater than 0. And so we're just integrating, and we're finding that area, so it's just the top minus the bottom. So it's really just the function 1 over x dx. And if I integrate 1 over x dx, then I get natural log, absolute value of x, evaluated from m to 2m. And then, if we keep going with that, the natural log of 2m, you're going to have natural log 2m minus natural log m. And then what can we do with that? So this is separated with subtraction. So we can put that together with division. And I'm going to move this up here. So that's going to be a natural log of 2m over m. And what's going to happen to those m's? Cancel out. So this is natural log 2. That's your area there. So what is going to be true about the area of this region? It is independent of m. So the answer is A. So number 2, you've got the region bounded by the x-axis and part of the graph of cosine of x between negative pi over 2 and positive pi over 2. So really, if you're not sure what that's going to look like, it's really just a parabola there. Because cosine, remember, does something like this and continues, and then it would continue back here. So we're looking at this portion from here to here, from pi over 2 and negative pi over 2. Is that okay? And then we're going to take a line that is x equals k, and we're going to divide that region into some different parts. We've got from negative pi over 2 to k, and then from k to pi over 2. So I know somewhere I've got this whole x equals k. Now I know it's over here on the positive side because k is positive, right? X equals k. So you know it's on that side somewhere. Does that make sense? All right, so let's look at how it's set up though. It's telling me that that line x equals k divides this up to where one part is a third and the other's 2/3, basically. So let's see, if we set up and we find this region here, if we tried to set up an integral to find that region, well, you're going to integrate from negative pi over 2 to k of cosine of x. Does that make sense? Now, I know that bounded region is 3 times, didn't it say 3 times? 3 times the area of this region. So in this region, to make these equal, I'm going to have to say 3 times, right? To make those equal, or make the other 1/3, either way. And so then I'm going to integrate from k to positive pi over 2 of cosine x Oops, I forgot my dx. Oh, bloody head. All right, so now let's integrate. If I integrate cosine, that's going to give us sine, right? And let's go ahead and plug in our endpoints too. We can do all of that in our heads. So that's going to give me sine, and it's going to be sine at k minus sine at negative pi over 2 equals 3 times, and then the same thing over here is going to be sine of pi over 2, isn't it? Minus sine of k. So sine of k, or sinc, minus, now right here, sine of negative pi over 2. That's really talking about sine of 3 pi over 2, because you're going backwards. And sine of 3 pi over 2 is negative 1. That's sitting down at the bottom at 270. Equals, that's going to be 3 times 1 minus 3 times sinc. Now solve this equation. I know that's minus a negative, so plus a positive. I'm going to add 3 sine of k over, so that's 4 sine k equals 2. And so that's going to tell me that sine of k is 1/2. So which of the answer choices is going to give me 1/2 when I substitute it in? Pi over 6. All right, so for the next one, we've got y equals, what is that going to be? X over 2. So if we draw, that x over 2 is just going to do a shift, and I wouldn't really worry about that shift so much. So the basic graph is going to look something like this. That point right there is going to be the point 0, 1 every time, never changes, unless you're adding or subtracting something. And then where else are we bounded? We've got it. Okay, so x equals 2, that's going to go somewhere right here, isn't it? So that's going to be x equals 2. And then x equals 0, that's the y-axis, and y equals 0 is the x-axis, right? So where is our bounded region? It's just going to be this little portion inside here. And you're just finding the area, right? So there's no big R, little r, just the area. So we need to integrate this. Our limits of integration, well, it's going to be from 0 to what? 2, 0 to 2. And then we're just integrating top minus bottom, so that's y equals e to the x over 2 minus y equals 0. So top minus bottom is just e to the, and I would rewrite that to be 1/2 x because it just looks better. So whenever you do this integration, I know if I integrate e to the x, I get e to the x. But I have 1/2 x. So one way you could do this is a u sub, and let's run through that right quick just to see, or you can do all that in your head either way. So I'm going to let u be 1/2 x. So du dx is 1/2, isn't it? And then we can cross multiply to solve. So I know 2 times du equals dx. And so when I come back over here to integrate, we have e to the 1/2. Oh, no, e to the u, isn't it? Is that okay? And then, let's see, dx is 2 du, so I'm going to put a 2 out here. And then do du. Is that all right? Now, the other way we could have done this is take the derivative of that exponent, which is going to be 1/2, and think about what to cancel 1/2, which is 2. And that you could have just thrown a 2 out here. Either way you want to do it, it's up to you. I don't care. All right, now we do either adjust our endpoints or integrate. Let's go ahead and adjust our endpoints. That's a good review also. Let's make those endpoints talk about u. So if I plug in 2, I'm going to get 1. If I plug in 0, I get 0. And if I integrate e to the u, I just get e to the u, right? And so then it's top exponent minus bottom exponent, or bottom endpoint, sorry. Now, look at this distractor. That is not the correct answer, but it's a good distractor because kids are going to say this is 0. And so they're going to choose that wrong answer, where this is really 2 times e minus 1, isn't it? So the right answer is C. And I know I probably need to do a sketch there. Also, since we're finding the bounded area, we also will need to find a point of intersection for these, don't we? So there's a couple of things you're going to have to find. I do know this is a parabola that's flipped upside down. I would go ahead and factor it just so that I have an idea of what's going on with it. So if we do factor it and solve, that's going to be 0 equals negative x squared plus x plus 6. I'm going to go through and rearrange and get rid of that negative. So we have 0 equals x squared minus x minus 6. And so that's going to give me negative 3, positive 2. Is that okay? And now let's go ahead and solve. So I know we're crossing the x-axis at 3 and at negative 2. So I know I have something that looks like this. We've got that upside down parabola. It's going to go somewhere like this. And I know from here to here, we've got from negative 2 all the way over here to 3, right? And then I've also got y equals 4. So that's going to have to come through here and cut part of that off. So really, I need those points of intersection. So, or at least the x values, so that I know my limits of integration, because I'm really trying to find that bounded area. Does that make sense? All right, so let's go through that. So again here, let's set 4 equal to negative x squared plus x plus 6. Move everything over, so x squared minus x minus 2 equals 0. And factoring that, that's going to give you x minus 2 times x plus 1. So our limits of integration are going to be 2 and negative 1. So when we set that up, we're going to integrate from negative 1 to 2. And this is where we definitely need that top minus bottom, because we're not on the x or y axis. So we're right there. So the top, that's going to be our negative x squared plus x plus 6, but then it's going to be minus that bottom function, which was 4. All right, now let's go ahead and finish the integral. We've got from negative 1 to 2, and that's going to be negative x squared plus x plus 2, isn't it? So we're going to have negative x cubed over 3 plus x squared over 2. Y'all with me? Plus 2x. And we're going to evaluate that from negative 1 to 2. So when we start chunking in some values here and you simplify, you should end up with C. All right, so number 5. We're in the first quadrant, and we're talking about y equals secant. So that's just a lot of floating parabolas. So let's think about secant is the reciprocal of cosine. And I'm just going to dot the graph of cosine. It's going to do something like this. Or cosine starts at 1. Now, secant's the reciprocal of this, so that tells me where this 0 is. We have an asymptote because the reciprocal of 0 is asymptote. And so whenever we do secant and we're just staying in that first quadrant, we're really taking that parabola and we're flipping it over. So really, there's what we have going on with that. There's the graph. Now, secant does continue to be all of these different parabolas. They're going to sit on top of those relative max and mins. So there's what the graph looks like. But we're just going to be looking at that and at pi over 4. So we're going to cut a chunk of this out. And that's x equals pi over 4. And then all of your axes. So you're looking at this weird region inside here. And you are revolving that about the x-axis. So here's your axis of rotation, which is nice because you are flush with that axis of rotation. So you can go ahead, there's no little r, it's just big R. So you're going to integrate from 0 to pi over 4. Of big R, which is going to be secant of x all squared dx. Well, that's nice because if I integrate secant squared, I get tangent from 0 to pi over 4. So what's that going to be? 1. Oh, pi. I forgot my pi. Omar. You didn't catch my mistake this time? Okay, our next example, we are told that we have a region enclosed by y equals x squared and the line x equals 2 and the x-axis, and we are revolved about the y-axis. So let's see if we can't get that one set up. We have a parabola, and we're really just looking at one side of that parabola. So we have y equals x squared, and then we also have the line x equals 2, that's going to cut this portion here. And so we see that we really are finding this little small area inside here. And let's see, we are revolving about the y-axis, so we're moving here. So it looks like we do have a big open space going on here. And something else, we need to find that point of intersection. So if x is 2, then y squared is going to be 4. So we have 2, 4. And also, since we're going with the y-axis, then we need to use our y coordinates. So 0 to 4. Also, if y equals x squared, and since we're going along the y-axis, we need everything in terms of y. So I'm going to take the square root. So the square root of y equals x. That's going to be one of our functions. So we are not flush with our axis of rotation. So our big R value is going to be from here, our farthest away function, all the way over to our axis of rotation. And so keep in mind that that's going to be my line x equals 2. All the way over to x equals 0. So we're going to have 2 squared minus, and then little r is going to be this portion inside here. So that's going to be the square root of y minus 0, or square root of y squared, and then dy. So we are integrating from 0 to 4 of 4 minus y dy. And so when we integrate that, we have 4y minus y squared over 2, and we are evaluating that from 0 to 4. And so when we sub in 4, we're going to have 16 minus 16 over 2, which is 8. And then if we plug in our bottom point, we have 0. And so we're going to have 8 minus 0, or 8. And then, oh, I forgot my pi again. We've got to make sure we have pi in there. So that's going to be 8 pi. So that's going to be answer choice A. Okay, the next problem, the area of the region between our graph of y equals 4x cubed plus 2 and the x-axis from 1 to 2. So a quick sketch here. We do have all kinds of things going on with this. Our parent function is x cubed. This is moved up to, so we have something that looks like this. And then we're going to have from x equals 1 to x equals 2. That's really giving me my boundaries from 1 to 2. So it is really going through and chopping off that particular area in the x-axis. So we're looking here. And so the area is really just going to be that function between 1 and 2. So we're going to integrate from 1 to 2 of 4x cubed plus 2. And so we're going to have x to the 4th plus 2x. And we are evaluating this from 1 to 2. And so that's going to give me 16 plus 4 minus 1 plus 2. And so that's going to be 20 minus 3, or 17. All right, and for our last problem on this set, we are given an interesting graph here, and we are asked to find the area shaded and, let's see, enclosed by these curves and the line x equals 1, negative 1, sorry. So I'm trying to find the area of that bounded region. So the first thing I would take note, notice you have a lot of different endpoints here. So if I'm finding that bounded area, so I'm looking inside this portion here, notice that whenever I integrate, I'm going to be going from, here is going to be negative 1 all the way over to a. So I need to make sure I have negative 1 to a. And notice with our endpoints, a is gone, b is gone, and c is gone. And notice what's left, we need to have our top function minus our bottom function. Well, this top function is f of x, and the bottom function is g of x. So that's going to be answer choice D.